Hello, Algebra 2. This is today's math video for Note 7 and homework number 8. The essential question is how do you use key features to graph a polynomial? And at the end of this lesson, you should be able to say that you can use the x and y intercepts, and behavior, and degree to graph a polynomial. Tonight's homework is assignment number 8. There's 2 graphs at the end of this video for homework. Okay, I just want you to listen for a couple minutes. So this is just a picture of different degrees. So the 0 degree is just a horizontal line. Degree 1 is just a line with a slant to it for the slope. What we've been working with is things like degree 2, degree 3, degree 4, degree 5. Remember, when it's an even degree, both arrows are up or down, but both arrows are in the same direction. And then the odd degrees, for like degree 3 and degree 5, one arrow's up, one arrow's down. And then this is just a little summary. So you're going to find and plot the x and y intercepts. So we're going to learn something new today. We're going to go over how to find the y-intercepts. The y-intercept. You need to ask yourself if the x-intercepts bounce or cross the x-axis. So we've been doing the ones that bounce. So that was where it was even. Remember, it had an exponent of 2. Those bounced. The ones that have an odd exponent, like 3, then those go through the x-axis. And let's see, end behavior, we've already talked about that. If your lead coefficient, right, if it's a positive or a negative lead, tells you whether the arrows go up or down. And so we're going to start from the end behavior to graph backwards through or bouncing off of our zeros, our x-intercepts, based on the multiplicity. That means the bouncing. Okay, so I want you now to go ahead and hit pause and write these 2 problems down. Write down the title. How do you find the x-intercept? The answer to that question is you plug in 0 for all the x's and do the math. Please hit pause. Write these 2, the words down, everything that's on the screen here. Remember, in the top left, you put notes number 7. And then come back to this video and we'll do them. Hit pause. Okay, so in order to find the y-intercept, we're finding the y-intercept. That's different than finding the x-intercepts. When we found the x-intercepts, we said one was at 0, -2, and +3. We took the opposites, right? But now we're going to learn about the y-intercept. And what that means graphically, it's hard for me to see on here, is where does a graph cross the y-axis? So where does a graph cross the y-axis? The x-intercepts we did before, they were up here, right? But now we're talking about that y-intercept, okay? All right, so how you do that, it's really easy. Let me just erase this little picture real quick. It's really easy, and it tells you right there. It says to plug in. Oops. Get my pen back. It says to plug in a 0 for all the x's. So right here, we're going to plug in a 0, bring down the parentheses, plug in another 0, keep the 2, keep the parenthesis, plug in another 0, and then just do the math. So our y-intercept is going to be equal to 0. What's 0 plus 2 inside this parenthesis? 0 plus 2 is 2. Next parenthesis, how much is 0 minus 3? -3. Now do the math. What's 0 times 2? 0 times a -3 is still 0. So our y-intercept for this one is equal to 0. So that means the graph, no matter what the graph looks like, and I'm not concerned about that right now, when the graph comes up, we're not talking about this dot, the x-intercept. We've been talking about those for a long time. Now we're talking about the y-intercept. When the graph comes up and down and up, right there at 0, is the y-intercept. That's where the graph hits the y-axis. So that dot, because remember now we're talking about the y-axis. All right, so if we need to find the y-intercept, we're just going to take the problem, and every time we see an x, we plug in a 0. This one's cubed, careful. So in all of these 3 spots, we plugged in a 0. Right? And then you just do the math. Okay, so I bring down the 4. 0 minus 3 in the inside here is negative 3. 0 minus 2, and then you got to cube it, is negative 2 cubed. And then the back one is 0 plus 1 is just 1. Now do your math. Do your exponents first. We have negative 2 cubed there in the middle. I'm going to do that off on the side. Okay? You're supposed to do your exponents first according to PEMDAS, right? So negative 2 cubed means negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. Times the back negative 2 would be negative 8. So right here in that parentheses, it's worth negative 8. I'm just going to bring everything else down and figure out what that equals. Could also run that on a calculator. Just make sure that you have the exponent of 3. Okay? All right, so we need 4 times negative 3. That would be negative 12 times negative 8. Times 1 doesn't matter at the back. So whatever negative 12 times 8 is, it should be 96 positive. Times the back one would still be 96. Okay, so our y-intercept, that would hit way up at 96, way up there. So whatever the graph would look like, be way up there and then come down or something. Well, actually, this one comes back up. It's an odd degree. Okay, all right. So this is going to be a continuation of your notes number 7. I need you to make 2 of these. So just fit it in at the bottom of your notes. Just make 2 graphs. Remember about the size of your fist. You should be able to fit it on the same note page that we've been working on. And the things we're going to have to figure out are x-intercepts, y-intercepts. Do things bounce or cross? What's the end behavior? What is the leading coefficient? And what's the degree? So if you want to go ahead and make 2 of these on your notes number 7 paper, hit pause, make 2 graph grids, and then I'll switch the screen and you'll be able to see the equation. So hit pause here, make 2 of the graph grids. Okay, so here's your first graph grid. Please write down this equation so that we can sketch the graph. So first we need to figure out the x-intercepts. So then we just go to the equation. This stands for 0. The next one, we take the opposite, so negative 2. The next one, we take the opposite, which is 3. So there's our x-intercepts. I'm going to go ahead and just switch colors here. And we can go ahead and plot those. One at 0, one at negative 2, and one at positive 3. You can plot them right away. Now we need to figure out the y-intercept. And remember, that's what we just learned. We plug in 0 for every x. So 0 and then 0 plus 2 and then 0 minus 3. Plug in a 0, plug in a 0, plug in a 0. That's how you find the y-intercept. So that comes out to be 0 times 2 times negative 3. And 0 times 2 is 0. That 0 times a negative 3 is still at 0. So the y-intercept is going to come right across at the same spot where the x-intercept is. Okay, the next question is, do they bounce or cross? These all cross. That means the graph is going to go through. It's going to go through, not bounce. And we know that because none of these up here, there are no exponents of 2 or 3 or anything. There's no exponent. The exponent it does have is a 1. It's hidden. But there's no x squared or x to the third. So there's no bounces. So no bounces. They all cross. What's the end behavior? Well, we learn what the end behavior is based upon how many degrees it is. So what is the degree? That's where you count the x's. So x times x times x is x to the third. The end behavior for odds is either both up or both down. Depends, right? What does it depend on? It depends on the leading coefficient. That's what this stands for. The leading coefficient is positive. So then we know our end behavior is both up. So now I can draw my arrows both up. So above the -2 and above the 3. And then we can do the wiggles in between. Okay? And we know that the y-intercept is also going to go through here. So down, up, down, and up. Oh, I missed it. Okay, I hope you do better. Down, up, down, and up. And I'm just going to draw a new arrow because I can't hit that one. And that's fine. So the y-intercept is also at 0. Okay? If yours is a little taller or shorter, that's okay. I mean, you could all, we don't really know the height of things. And this should be smooth and curvy. We really don't know the height of things. You'll learn more about that in pre-calculus next year. But as long as everything is curvy. All right, let's try another one. So you should already have another area to graph one more. Write down this equation. And get started. Okay, so we're going to find the x-intercepts. Hit pause if you need a minute. Okay, so now we have to be careful here because you can see that some of these numbers in the parentheses are different looking. So let's start at the beginning. There's no x next to the -2. The next one says x minus 3, so we know to take the opposite. So there's one intercept there. But how do we tackle this? Well, we actually have to write it out and solve it. You have to set it equal to 0 and solve it. So we have to add 4 to both sides, so plus 4. And then it would say 2x equals 4. I need some more room, so I'm going to move it up here. So 2x equals 4, divide by 2's. So x is equal to 2. So another intercept is at 2. So you actually have to solve it. Set it equal to 0. All right, so 2x minus 4 equals 0. To move the 4, you would add 4 to both sides. 2x equals 4. And then I'm just writing it up here. Then divide by 2. Or you should know 2 times what number gives 4. You should know the answer is 2. Right? Okay, so that's how we got the second intercept. And then the last one in the parenthesis over here, that one we need is -1. So let's go ahead and put those on our graph. So we have 1 at 3, 1 at 2, 1 at -1. And remember, if there's just a number right here, not an x, right, we're not really using that as an intercept at all, right? Okay, now we got to find the y-intercept. That means wherever you see an x, you plug in a 0. And so here it is done for you in blue. So finding the y-intercept, you plug in a 0. And then we have to do that math. So I'll wait for you for just a minute. You might take a minute to be writing that down. You plug in a 0 every time you see an x. So right in here, this becomes 0, this becomes 0, this becomes a 0. All right, you're putting in zeros. I'm just giving you a minute to do that. Okay, we're finding the y-intercept. Okay, so -2, do the parentheses first, it's -3 squared. And then inside here, 2 times 0 is 0. Minus 4 would just be -4. I'm going to write -4. And the back one, 0 plus 1 is 1. And then we have to do the math. Do the exponent first. So we have to do -3 squared first. So -2 times 9, because -3 squared means -3 times -3, which equals 9, right? And then -4 times 1. The 1 in the back isn't going to make any difference, is it, you guys? Right. Okay. So -2 times 9 is -18 times a -4 is positive 72. No. It'll be too late in the day. Let's see. Grab my calculator. No, it was 72. Okay. So our y-intercept is way up there at 72. So if we were going to plot it, it's practically off the chart. I mean, it's way up there, way, way, way up there. It's off the chart, but that's okay. All right. Okay, so do they bounce or cross? Let's go back to the x-intercepts. So do the x-intercepts bounce or cross? So you're looking for exponents. Right here's an exponent. So you're going to have a bounce because it's an exponent of 2 right here at this 3. So you're going to bounce at 3. So right here, positive 3, we got to remember to put a bounce in right over here, right? On the graph, we got to put a bounce there. That's where it's just going to touch the x-axis. What's the end behavior? Well, we have to check our total degrees. So count how many total x's. So x squared, x, and x, right? X squared, 2 of them, another one. So we have degree 4. What does that mean for end behavior? It means either both, when it's even, degree 4, either both arrows are up or both arrows are down. Which set is it? Depends on your leading coefficient, and that's a negative lead coefficient. Because, let me erase these, it has a lead of -2. So not both arrows up, but both arrows down. Both arrows are down. Okay? So we know that over here, both arrows will be going down. We also know that we have to have a bounce at 3. So here was the 3, here was the 2, here was the -1. We have to have a bounce at 3 because it has the exponent on that one intercept, right? Right here, the exponent of 2. So I got a bounce from there. So I'm going to move this arrow over a little bit. So I'm going to come up and I'm going to bounce at 3. Bounce at 3. I'm going to go down and up and down, and we're done. We have a bounce at 3. Okay? All right, if you need a minute, you can hit pause. Okay, so homework number 8, you'll need a new piece of paper. It's on the next 2 slides. You need to graph both of them on one piece of paper and show your work for the key features. So list out, where are your x-intercepts, what's your y-intercept, what's your degree, okay, what's your or your lead coefficient. So list out your key factors, what's your end behavior, okay. So let me show you those slides. So this is the first one. It's example number 1. Please hit pause while you write that down. And then the next one, number 2, is right here. Here's number 2. Please hit pause and write that down. Okay, make sure everything gets uploaded to your digital workbook. Thank you.